So what is this correlation coefficient? What is this all about? Well, before I even talk about what it's about, before we define it, let me just create random scatter plots. Don't copy this down. Just pay attention. If we had an x and y axis like this, and then we do a scatter plot, you can kind of see there's a downward trend there. The bigger the x gets, the lower the y gets. There's a downward trend. What if we were to do this here? Notice the scatter plot's a lot more tighter around a line. There's a stronger negative relationship between the x and y. Right? So you can see the trend here, but now they're a little more compact and tighter around a line. And yet, even more tighter, right? So we get from a weak relationship, look at kind of scattered, stronger, and even stronger, until the strongest it can possibly get is in exactly a straight line of whatever data we're calculating. That's called correlation. Weak correlation, strong correlation, very strong correlation. Correlation just means connectedness. Okay? You're going to hear this word a lot when you get to university or college. Those of you who are going to college, you have to know what correlation means. When two variables or two things are connected somehow, we don't know how they're, if one's causing the other or the other one's causing the other, we don't know yet. But there's something going on. There's a relationship between two variables. We're going to actually calculate one about you today. Okay? Just thinking out loud. Is there a correlation between the number of times you've been arrested and the number of times you've been fired from a job? Think about that. Sorry about that. So let's say we're to graph it. Number of arrests and number of times fired. Would it be downward or would it be upward? In other words, the more times you've been arrested, would it be the more times fired? Would there be an upward tendency in that? I don't know. I'm just thinking out loud and giving you examples of what scientists can measure in reality. Is there a negative correlation, a positive correlation, or no correlation? In other words, sometimes it's the case you have this. There's no relationship. There's just data scattered all over the place. I can't draw any line of best fit. That would be no correlation. So that's where we're headed. There's a number that describes how strong or how weak a correlation is. And that number is called the correlation coefficient, which is your word that we're about to define. Here we are. Go and write this down. It's a small paragraph, but it's okay. Correlation coefficient is represented by, go and write that down. We're going to spend the last days of class talking about correlation coefficient. Go and write that down. If you're watching the video, go ahead and pause right now and copy this down. So minutes is your x-axis, y is cars washed, that's your y-axis. Maybe go by 2s on the x-axis since we're going all the way up to 24. I would maybe go by 2s. And then just go by 1s on the cars washed. Let's see if there's a relationship between the two. So we'll first create the scatter plot and then we'll calculate R. Go do that for me. How do we calculate R value? Here's what we're going to do. You're going to go to Google Chrome, the Chrome browser. Go to where it says Google. Make sure that you're signed in, by the way. This is your account. Then what you're going to do is you're going to go to Apps. Look at that little Apps button right here. Fuentes, you're stressing me out. You with me here? Come on, let's go. So Apps. Let's go to sheets here. Okay. These are spreadsheets. Let's do a blank one here. Can press blank. Has anybody used Google Sheets before? Raise your hand if you've used them. Okay. We're gonna type in the data now. On column A, look at column A, I'm gonna type in all the X values of the data. Column B, I'm gonna type in all the Y values. So the X values was number of minutes, and the Y values was how many cars washed, I believe, if I'm not mistaken. So let's go ahead and do that right now. Do that with me. Let's type in our data. AC will turn on right now. Sorry for it being stuffy. All right, so the first ordered pair was 6 what? Can anybody give me the first ordered pair? 6 what? Let's see. 6-3, thank you. So 6 minutes, 3 cars washed, okay. Yeah, so 6-3, 10-5, here we go, stay with me. So 6-3, 10-5. Make sure you're not getting that on my computer, right? You're awesome. 14-7. 20-10? Awesome. 24-12. Okay, so there's my X values and there's my Y values. So I'll wait till everyone's done. All right. Here we go. Now, R is called, what's the title of that handout I gave you? What is R called? Starts with a C. What's the title of the handout? Correlation coefficient. That's what R is. Look what I'm going to do. I'm going to pick any empty cell. Look at, what cell do you want that's empty? Look at, I'm just clicking in. Doesn't matter which one. I'm going to tell the computer now to calculate the correlation coefficient of this data. And now remember, our data look like this. Before I even show you how to calculate, our data of car wash and minutes, you guys agreed, looks like this. So when the computer gives us a number, it should be very close to +1, the R value. We haven't done it yet, but I'm expecting a number very, very close to +1, the correlation coefficient. So this number that we're about to tell the computer to do is kind of like a grade. It's a grading number. How strong is the correlation between minutes and cars washed? How strong is numbers of arrests and numbers of times fired? How strong are these two variables? Watch this. Here we go. So you have your data in front of you. Here we go. So you just pick any empty cell. And here's what you're going to write. You're going to put equals. Type in equals. Whenever you're using sheets, that's telling the computer, look at here, you're going to do something for me now. Here's what you're going to do. You're going to give it a command. Go ahead and type in CORREL, or just CORR, and you'll see this coming up, the correl function. And look what it says. Look what it's called. It already kind of anticipates what you want it to do. It says Pearson product moment correlation coefficient. Look at that. I'm going to go and press that. And now the computer's asking you, hey, sir or ma'am, what data values do you want me to calculate the correlation coefficient for? Well, right now I'm gonna highlight my X values. Look at starting with cell A1. Look at this first X value of 6 is in A1, and I'm gonna drag it down to the last. And I just messed up. Something went wrong. Please reload. I'll do that again. You guys shouldn't. I'm gonna drag it from A1 all the way to A5. Let me do this again. I may have too many things open. Give me a second here. Here we go. So here we go. Let me do it. Equals CORR. There's my correlation coefficient. Now it's asking me, okay, what data values? My first data value is A1. Look at now. I'm going to drag the mouse all the way down to my last X value, which is A5. Look at so it says A1 colon A5. I'm going to put a comma now. Look at this. Comma. Okay, now it's asking, okay, what Y values? Well, my Y values start at B1. Look at B1. I'm going to drag it all the way down to B5. Those are all my Y values. Let me close my parenthesis, and let me press enter, and look at the R value it gave me. It gave me an R value of 1. That's exactly what I was expecting. We have a perfect positive correlation. In other words, we have this, positive 1. We have that graph. We're expecting a positive 1 R coefficient. Whenever you have, like, say, 0.999, that's actually a good positive correlation coefficient. It's not perfect, but it's very close to 1. So let me go back here. Let me do that again. I could tell some of you are, I'm seeing a deer in the headlights look from some of you. Let me do it again. I press equal. Let me zoom in a little bit here. Okay, so let me press equal. I pick any empty cell. Every box is called a cell, by the way, a cell. Equal, C-O-R-R. Look at this comes up. I press correlation coefficient function. Now it's asking me what x values, okay? The first x value is A1. Look at, and it automatically puts it in there. I'm going to drag it down to my last x value. Look at colon A5, comma. Now y values. B1, drag it all the way down to B5. Close a parenthesis. And there's my correlation. Let me press enter. There's a correlation coefficient of 1. Perfect. Okay. That's boring to me, that data. Cars washed or the minutes in cars washed. What I'm going to do is now I'm going to have you guys be my guinea pigs. I want to study something about you guys. I want to see how strong a correlation is there between your absences and your grade for every student in this class. So on my x-axis now, we're going to do the correlation coefficient of something about you guys, real data about you. Here's how we're going to do it. You have that piece of graph paper I gave you. I'm going to plot on my x-axis how many absences you guys have, each individual person in here. Now it's going to be anonymous, so you don't have to worry about being known or being embarrassed. But what I'm going to do is I'm going to plot absences here on my x-axis. I want to see what the correlation is between absences and grade in my class with my students. I'm going to go by tens for the grade. So 10, what's your grade in percentage? So do this with me now. So grade is on my y-axis. We're going to end class with this one example about you guys. So grade. You guys have your computers because you're going to be able to check your grade right now. And then absences, we're going to go by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There's some students that have a lot of absences in here, believe it or not. My hypothesis, you guys remember what a hypothesis is in science? Yeah. What is a hypothesis, Fuentes? It's an educated guess. My educated guess is this, and I'm going to test it. I'm going to graph the data and see if there's a positive correlation or a negative correlation. Here's my hypothesis. The more absences students have, the lower their grade's going to be. I'm going to see a downward trend. And we're going to use real data from you guys. I'm even going to get the absences and grade of the students who are absent right now. There's some students who are absent. There's Valero who's absent. There's, who else is absent right now? Oh, Arcos. Arcos is absent. I have his data. I'm going to plot it. Oh, yeah, Rodriguez, Victoria, she's absent. And Mercado. But Mercado, actually, she finished. She's a TA now. So here's what I want you to do. I'm going to give you a little piece of paper. I'm going to tear it off. So it's going to be anonymous. All you are, you're just going to be one dot. You're going to be one ordered pair. And no one's going to know who you are, so don't stress. What I'm going to have you do now is, on this little piece of paper, give me the number of absences for my class only. So when you go to Student Connect, you can see the number of absences. If you look at your grade, it tells you how many absences you have. So I want you to total the amount of excused and unexcused absences. That's going to be your x coordinate. So your absences, excused and unexcused. So I want to know how many times you haven't been physically here in my class. And then, what's your y coordinate going to be? Your grade, your percentage. So I'm going to come around and give you a little piece of paper. I'm going to test my hypothesis. I think there's going to be a downward trend. The more absences, the lower your grade. I think you know I'm going to be right too. Well, we're actually going to test it out though. Here we go. Here we go. So let's calculate our R coefficient, correlation coefficient, 147, 231, 161, 017, 025, 53, 430, 'So for your stamp, you got to give me the R value. 13, 14, 15, 9%, 922, and then 444. 15, 9. Go ahead and type those in. So if you type these data values in, you should get an R value. So everyone just put this on their notes. R is equal to negative 0.30. We're going to round the nearest hundredth. How close is that to negative 1? Well, let me look at my scale. Let me look at my scale. My scale was right here. So it was kind of on the weak side. So here's negative 1, right? It was kind of looking like this. It's a weak negative correlation. So we're expecting, look at a negative, here's negative 2, negative 0.2, negative 0.3 right here, negative 0.5 would be in the middle. The closer it gets to negative 1, the stronger it gets. The closer it gets to 0, the weaker it gets. So it was close. Our value was negative 0.30, negative 0.3. So it's weak. It's a weak negative correlation, but it's still a negative correlation. It's weak though. The closer to 0, the weaker it gets. There's no correlation. That's why the scatter plot that has no trend is a 0. So ours is a negative 0.3 correlation. Raise your hand if you got negative 0.3, and you can pack up. Or, sure, let me put the data up here. If you don't have that 0.3, go ahead and practice till you get it. There we are. Go ahead. Practice till you get it. Let me see, negative 3.0. Awesome. Go to mathisfun.com or Cool Math Games.